Did you find it? You did find it? Okay, so you should be looking right here. Parameters of sampling distribution for one population X bar. So this is the center. The center of that dot plot is going to be the true mean. So mean of X bar equals the mean. And we can use that because the mean is an unbiased estimator. We already showed that back when we were talking about those four guys and their heights. We found the averages. And then the spread is right here, but leave a space. So standard deviation of X bar is the standard deviation divided by the square root of n. And I want to talk about this in a second. But remember, in order for us to be able to do standard deviation, we have to check the 10% condition. So and again, the goal here is to do normal CDX. So we're going to talk about things being normal today, but the whole point of this is to be able to find a mean and a standard deviation to plug into normal CDX. Okay, now the next thing I want to talk about is why this seems weird. I don't know about when I first was learning stats, I thought that that makes sense. Okay, so the center of the dot plot of all the averages is probably the true average. That makes sense. Okay, so let me do my thing again. I'm flying around the world and I pick 5 squishmallows, okay? You see me with my little cape? It's got a big S on it for squishmallow. And I'm flying and I randomly select 5 squishmallows and I measure them all for their height. And then I average it, right? And then I fly back to my little stats notebook and put a dot at the average. And then I fly out again and pick 5 more squishmallows and average it. And would it make sense that if I got all possible samples of 5 squishmallows, the middle of that dot plot should be the true average height of a squishmallow everywhere? That make sense? That the middle of that dot plot should be the real average. Okay, but why is the standard deviation of that dot plot the real standard deviation divided by something? Wouldn't it just be the real standard deviation? Okay, think about averages. Averages mean that you're taking something and squishing it together, right? You're bringing it to the middle. And remember that I said that smaller variability is better. And what makes things smaller variability? Larger sample size. So the larger the sample size, that means the squish down your dot plot's going to be, which is good. So this is dependent on how big your sample size is. And it's in the denominator making it smaller, just like we talked about back there. Remember Jamie's excellent question about the n versus the 4n? Same thing here. In the denominator, when the denominator gets bigger, the actual fraction gets smaller. Okay, so let me draw you a little picture. You don't have to draw this picture, but just for now. Tomorrow I'm actually going to show you something on the computer, but let's pretend that this is a histogram of all possible heights of squishmallows, okay? Oh, it looks like a city. It's supposed to be a histogram. Okay, and then I take a sample of 5 squishmallows. Okay, and then I average those. My average would go toward the middle. Does that make sense? So that means that my dot plot of averages is going to be actually skinnier than the original population. Okay, so original population, lots of different sizes of squishmallows. Sample of 5 squishmallows. I average the numbers. The average is going to suck it toward the middle, and my dot plot's going to be skinnier. Are you following what I'm saying? Because these are plots of averages. Averages are going to be toward the middle. Okay. Now, did you guys write this already? Okay. I'll pause right here. Okay, let's do this first one. The length of human pregnancies follows a distribution that is approximately normal. Did you guys know that? Most medical things do, with mean 266 days and standard deviation 16 days. Find the probability that a randomly chosen pregnant woman has a pregnancy that lasts longer than 270 days. This is actually a chapter 2 question, not a chapter 7 question. So we're going to say probability X is greater than 270 equals normal CDF. Okay, now longer than 270. What's the low then? 270. High is 10 to the 99. Mean 266. Standard deviation 16. Low, high, mean, standard deviation. Zero 0.4013. Okay. Now, suppose we take a simple random sample of 6 pregnant women. What is the mean of the sampling distribution of X bar? The mean of the sampling distribution is still just the mean. Okay, I drew you a little picture while you're writing. I hope for my visual people out there. So I drew this graph with a mean of 266 and a standard deviation of 16, and I went up 16, up 16, up 16, down 16, down 16, down 16. Okay, now I'm going to make a graph of the sampling distribution down here. It's going to be a crazy dot plot, except for that I'm going to estimate it with a normal curve. Does it make sense to you guys that the center of it is still going to be the same as the center of this? Okay, is that okay? Okay, now calculate and interpret the standard deviation of the sampling distribution of X bar. Verify the 10% condition is met. Okay, so N equals 6. Do you think that's less than 10% of all pregnant women? Yeah. I think that's a safe assumption. Okay, now calculate the standard deviation of the sampling distribution, and that is 16 divided by the square root of 6. Do you see where those numbers came from? Do you actually see where those numbers came from? 6.53. Okay, now, just before we interpret, come back here. So the standard deviation of the sampling distribution is 6.53. So if I go 266 plus 6.53, that gives me 272, which is like right here, plus 6.53, 279, which is like right here. Man, I must have estimated that wrong. Plus 6.53, 285. Okay, so if I go out the same amount on this side, that's terrible. But do you see what I'm trying to say? Because you're taking averages of this, the sampling distribution is much less spread out than the actual original population. Hello? Because you're taking numbers from here and averaging them so they get closer to the middle. Okay, yeah. So this is just one person, but this is 6 people. Average of 6 people. Okay. All right, now, how do we interpret this? last thing, actually, believe it or not. What is the big hint in this problem that you're in chapter 7 and not in chapter 2? What is the big hint that you're in chapter 7 versus chapter 2? Okay, so up here, you were in chapter 2. Find the probability that a randomly chose pregnant woman has a pregnancy that lasts longer than 270 days. Okay, how do I know in this problem that I'm no longer in chapter 2, I am in chapter 7? 6 women. Okay, so scroll back up here. This one says a randomly chosen pregnant woman. There's just one. Now you'll have 6. Okay, that means that you need to use the formulas in which you use the 6, which are these for the mean and standard deviation, not just 266 and 16. Hello? Do you understand that the 6 means that you have to use the formulas that involve the 6? Okay, because this one said 6, and this one said 6, and this one says 6. So you need to use the ones that say 6, not the ones that's just 1. It's the ones with the 6. Okay. First part's still the same. Mean is still the same, but it's much less spread out because it's 6 women. And I don't need to label anything on here because this part takes care of the first 2, and I already labeled the mean and standard deviation above. But what I can do is be extremely lazy and just change this to be 6.53. Okay, so you're going to have to keep your eyes open for when it's more than 1. When it's more than 1, that means you're in chapter 7, not in chapter 2, and you're going to have to use the formulas for more than 1. The mean is the same. It's just the standard deviation that changes. Alrighty. Let me see if I have a joke for you. Hold on.